This video is about relative motion. You're trying to cross a river, and your boat can move at some certain speed in still water, but there's a current. Or, you're walking along and you throw something while you're walking. Or, you're on a train that's heading east and you see someone out the window who's moving west. If you come across a kind of convoluted setup like this, you've stepped into the realm of relative motion. Relative motion is a kind of problem that looks particularly complicated and difficult, but it's actually a familiar kind of problem that's just disguised as something tough. Let me show you what I mean. Maybe I'm on a raft in a river. Let's make a river. I'm on a raft in a river, and I see a branch floating down the river. There is a branch in the water, and that branch is moving just down the river. I can see how I am moving relative to this branch. Call this the velocity of me. Call this the velocity of the branch. I would like to know maybe how fast am I moving relative to the shore. I really just need to organize my thoughts. The branch is stationary relative to the water. There must be some kind of a current, and it's not like the branch is out here paddling. I can see how fast I'm moving relative to the branch. So this is the velocity of the branch, or of me, relative to the branch. I'm writing subscripts like this so that the top letter represents the object, me. So this is the velocity of me relative to the branch. The top one, the top subscript, represents the object. The bottom one represents my reference point, the branch. I can also see how fast the branch is moving relative to the shore. Branch to the shore. If I would like to know how fast I'm moving relative to the shore, I just need to add up these velocities. Velocity of me relative to the shore is going to be the velocity of me relative to the branch plus the velocity of the branch relative to the shore. I'm using these subscripts to act almost like dimensional analysis. The b on the bottom of the first quantity, right here, cancels with the b at the top of the second quantity, and I am left with an m on top, an s on the bottom. That is what I'm looking for. All I have to do now is add these quantities. I have to add them as vectors, so I may need to break some vectors into components, but I know how to do that already. Not a tough problem. I'm going to give you another scenario. Maybe I'm still on this kayak and I see a crocodile in the water. It's just its head. And I see how it's moving. Maybe what I can see is how the crocodile is moving relative to the branch. Oh no, I need to know how this crocodile is moving relative to me. That seems like a very pertinent question. So I have how I am moving relative to the branch. That's a quantity I already had. Now I also have how the crocodile is moving relative to the branch, and what I need to find is how the crocodile is moving relative to me. I want to start with what I can. I'm looking for how the crocodile is moving relative to me. I know I'm going to need some kind of a way to get crocodile on the top of my fraction, and here I have that. So let me start there. Velocity of the crocodile relative to the branch. I need to add something to this. So I want to cancel out that branch, and I need an m on the bottom of my fraction, on the bottom of my subscript. I have this thing that would work great if I had the branch on top and me on the bottom. So what I would really like to do is be able to do this. Branch on top, me on the bottom. Here is the trick. The velocity of the branch relative to me is the opposite of the velocity of me relative to the branch, and you already know this. If I see you moving 10 miles an hour east relative to me, you would see me moving 10 miles an hour west relative to you. So in more mathish terms, this means the velocity of one thing relative to another is equal to the opposite of the velocity of the other thing relative to the first. So the velocity of the crocodile relative to me, that's the velocity of the crocodile relative to the branch, plus the velocity of the branch relative to me. I can take this thing and use it to find this value that I didn't have. So I can say that is the velocity of the crocodile relative to the branch plus the opposite of the velocity of me relative to the branch. Now I'm right back to a vector addition problem. I'll run through an example of this in a separate video that uses numbers and actual quantities and everything, but for right now, that's relative motion.